So welcome to this course, Advanced Simulation and Prescriptive Analytics. So sometimes I like to think about what would this title mean. So for some of you, it will mean like advanced simulation, one topic, and then prescriptive analytics, another topic. But you can also think in that way, but you can also think in another way is I think simulation and prescriptive analytics, they are studied together. And then this will be an advanced course because as I asked before, you study Facts Analyzer as a basic simulation optimization software in 1TS course about logistic modeling and optimization. So when you come to this course, I think it's a more advanced version. So we are not going to look at the very basic simulation. We try to be more go deeper, and then the relations, how simulation can be used together or can be used for prescriptive analytics. So those terms will be defined. I probably have never met all the students. Of course, here we have some PhD students with me and even some company people, but my name here, you can see, and probably you already know that met me in the earlier course. I'm the visiting professor in Uppsala University. I don't have a telephone number in Uppsala. So in case you want to contact me, I think email will be the easiest. And then of course, in Canvas, you have the email system inside Canvas within the course. You can also contact me through there. And then I have been a professor in Skövde for quite many years. So when we start this course, later today, I have some overlap of my PowerPoint slide and also the Canvas page. We will go through the Canvas page together. If not in the first hour, will be the second hour. But some of the important information I have gone through earlier with you in the introductions when I introduced the course to invite you to join. I think you have seen those slides before. So this kind of learning outcomes and contents, you can find it in the so-called course plan. I don't need to read them word by word, but you know that in this course, we try to clearly define those terms: descriptive, predictive, and prescriptive analytics. And then, of course, we will be pretty much focused on prescriptive analytics, the last word. But of course, there will be something related to descriptive and predictive as well. And if I'm not wrong, I think you studied the course with Max Gustafsson in artificial intelligence. So you have some basic background in neural network as well. So it's good because that will make you easier to understand what I mean by predictive analytics. I think neural network is a pretty common universal approximations functions for doing this predictive analytics. So a number of analytics methodology we talk about here. So optimization is not new to you, not data mining. And then data mining usually get associated with a visualization and sometimes pretty much overlapping between data mining and machine learning. So this will be the technology we are going to look into. But the key here will be how we combine with simulation for the purpose of understanding and analyzing industrial business system performance. So some technology you have already studied before or you have heard about the terms. Matthias wants to have a new course in the future to talk about process mining. So that will be one part that I will cover a little bit more later, just like an introduction. But the key will still be how it relates to simulations. And then when I point here about the industrial and business systems, and even in later slides, you sometimes find healthcare. So for me, I think when we study system engineering, my background is pretty much in manufacturing, but you will find that this kind of principles and knowledge that you're going to gain will be also related to business and healthcare. So as long as you have some process, and then they are linked by certain logic decisions, and you need to study their performance, I think the knowledge you gain here will be useful. So either industrial business or even healthcare system. This is something quite generally I have written in the course plan in other course slides. So it's not only manufacturing, but because of my background, you will hear more about manufacturing production system example. And then you need to also not just know about the technology, but know about the advantages and challenges when you use different techniques to apply to real-world industrial settings. So part of the course will be about pretty academic. We will talk about some hypothetical, simple models. But you can reflect about if this kind of principles, how would you apply to real industrial settings? I think this is also an important outcome. And then I purposely highlight here, one interesting thing for this course will be you will have a project work. We will talk more about course assessment. So sometimes many students are pretty critical about what kind of grading scheme and also the course assessment. We will talk more about later, even though I have some information on Canvas. But designing, modeling, and optimizing a self-designed production system, I think that will be interesting. I'm here testing a totally new concept. I will tell more later about my history about teaching this kind of concept. So in terms of simulation, I've been teaching for like 15 to 18 years. But this year, with this class, I want to test a totally new concept. Is that you have the opportunity, I think it's more correct to say that you have the opportunity to design your own model, to define your own problem, and then to try to solve it by yourself. And then not only about that, of course, you can relate to some literature, and then using the software, using the tools that you're going to learn in the lab, as some sort of experimentation platform. So you can also relay it back to some theory, something you find in the literature. So this is the learning outcomes, something you can read on the course plan. And then come to the course contents. Roughly, I think you can divide the course into 4 parts. So in Canvas, there are also divided into different modules. And today, I mentioned in this first module, from this week, we start the lecture today, and then next week 44 and week 45. So that will be module number 1. So we are going to look into the design of an event-driven and object-oriented programming for simulation. So the first part will be about discrete event simulations. So you learned about discrete event simulation before, but now this time we go much deeper. So we are going into how we can manipulate the simulation engines in a quite detailed way using programming, and more specific will be object-oriented programming in order to have a more detailed control about the model. And then the second module will be about different strategies and principles. I have a long list of things that we'll cover, some keywords here. So these are some of the principles relating to some objects we can manipulate in simulation to represent the real world. So, but the keyword here is about the principles. So through studying the behavior of these objects, and then you can define your own logic, for example, like control and dispatching. So we are going to observe using optimization how those principles will be in actions. So if the first part will be advanced simulation, the first module, then I think the second module, you can call it like principles. You can see it on the Canvas page. And then the third part, of course, is prescriptive analytics. So you studied some multi-object optimization before, and they are pretty much non-interactive. So we are going to look into some interactive optimization algorithm. And then together with an analysis method, clustering, decision trees, association rules, even a little bit neural network, we're going to see how this kind of data analytics can be combined with optimization for performance analysis and improvement. So finally, I think this about the methods and algorithm and so on. And then something new for you, and I don't know whether it's good or bad, is I mentioned about, I think I have this is more like a picture. I also mentioned about the course content will be a Lego building blocks. I think I have the same thing on the next slide. Okay, one more line here. So I have been using these principles for now, I think 7 or 8 years in another course in Hertha about the interleaving theories, hands-on application throughout the whole course. So sometimes I even in the lab, I give some briefing, some lecture about some theory, and then show some demonstrations, and then the student will continue to do some hands-on. And finally, they will look into if the hands-on skills they have acquired can be applied to a larger scale industrial applications. So this is what I mean by interleaving theories, hands-on, and application throughout the whole course. So in my experiment in Herb, I think it went pretty well. So usually it's not simply very boring that you just need to listen to me for like several lectures and without doing anything. I suppose that you will do quite much yourself through this kind of online tutorial, and sometimes we will do it also together at the campus. But anyway, I think the key thing I'm using here, and this is not a new thing. The new thing I'm testing is that you're going to build your own model. But in terms of the interleaving theories, hands-on and application, I think I've tried that for quite many years. So the next slide will be more pictorially about what I mean by those 4 modules. So notice the number here. So we start with advanced simulation modeling using C++. I think in one of the last lecture, I asked some of you, and unfortunately, I don't know many of you know about C++. So that will be a bit tough. I think C++ is not an easy language, but I'm going to give you some crash course next week. Anyway, I will keep emphasizing to pass this course is not very difficult, but of course to get a good grade, I think you need to work harder. But C++ is not something easy to master, but to manage to do the tutorial, I think I can give you some enough material so that you can do it. And then I know some of you already know about MATLAB, but unfortunately this year, I planned to launch this so-called PLAT-EMO platform on MATLAB so that you can run your own optimization, even customize some of the parameters. I think some of the PhD students here, they know that they used the PLAT-EMO before, but unfortunately, I don't know whether it's good or bad. I'm not managed to make it happen this year. The reason is the extension in the C++ to make the executable file is not able to work this year. I think the programmers in Iroma told me that they need to have some more time later in Christmas to make this MATLAB and then the C++ executable file working together. So that's why this year you will not have this so-called PLAT-EMO platform to run. But then it will be something else that you're going to try, and that will be Python based. And since you learn Python, now I need to ask a question. If some of you can answer me in the chat, did you learn this Python with Max Gustafsson when you studied the new level course? Maybe the general question is, did you study Python in other courses? I know that you have a MATLAB before, and then even go back to your undergraduate.
Yeah, I've studied Python before.
Yeah, okay, good. Then I think it will be good that I will replace the PLAT-EMO with a Python-based platform that you can try. So I already start to talk about the second part. Okay, we talk about this systems engineering theory, about the principle. That will be the second part. And then the third part will be prescriptive analytics, both using the algorithm and back the effects analyzer in some more advanced version, many objective optimizations. But then the data analytics part, we will do some exercise using some Python-based platform. And finally, of course, we talk about this application. So roughly, you can see that we divide the course into these 4 modules. And then I keep saying that try to make the course contents to be more like Lego building blocks. And then so that you can do your own scientific experimental project. So before I move on to give you further definitions about more details about simulation prescriptive analytics, and then look at the Canvas page, I think there are certain principles, maybe even philosophical things that we can talk about studying this course. So I think the first interesting philosophical things, and then totally, I think there are 3 things. So let me just use hopefully around 10 minutes to explain how you should approach this course. Maybe it will be a little bit different from other courses, but I think for master level students, I think you will understand what I mean here. So let me show you something here. There are 3 principles I want you to remember when you approach this course. I think the first principle, I would like to call it think free. Okay. And then if I need to cite Simon Sinek's term, I think it's an infinite game. And I write here, life is an infinite game. I think you can read about the quotation here. I don't try to read everything here for you. But something interesting to tell you is my background was in manufacturing. And then when I studied my own undergraduate courses, I don't really remember. I don't even have the transcript, but I think 1/3 of my course I got an A grade, and then the other would be B and C. So it's quite ironic that today, even though I'm a professor in simulation and optimization, but the only D grade I got was in the course of simulations. And what happened was when I studied my own bachelor and even master, I like to use one trick was if the lecturer, if the professor mentioned about some textbooks, I usually like to stay in the library. You know, I was more like, when I studied, I was more like a pre-iPhone and pre-internet ages. So even though I don't think I'm much older than you, but anyway, when I studied my university, it was a pre-internet ages. So I stay quite much in the library. So I like to stay in the library and try to find other books. That means that the books not recommended by the professors, but I find that it would be relevant. And then during the exam, I will try to impress the professor by writing something that never find in the textbook or not directly in the same textbook that he or she provided. So that trick worked pretty well. I think most of my A grade courses, I think I got it that way. But unfortunately, the course simulations, I think I got a D. The reason was because the professor didn't like me to answer something outside the textbook. He wanted me to answer something almost exactly as what could be found on his lecture notes. So this is not the way I'm going to approach this course. And that's why I write down here, it will be free. I think there are many things to discover. And while you learn simulation, you want to solve practical problems. We are not dealing with a mathematical modeling that you are only refined to certain predefined problem with assumptions. So learning simulation is allows you to able to make a very complicated logic, realistic logics, and so on into the model. And that's why I want to emphasize the first thing will be when you study this course, don't try to limit yourself by thinking that there are only some standard models and standard textbook that you need to go through. So if you belong to this type of students that you only want to read one book and then want to pass the exam, I think I know how to help you. I will tell you what to read, even though it's not only one book, there will be a lot of articles and so on. But passing the course is not difficult, but to get a good grade, I think you also need to show me that you have discovered something new. At least you try to think free. Okay, so I think this is the first principle. And then some of the topics I cover, of course, I have some experience, but I cannot admit that I'm good, everything here. So I'm much better in manufacturing theory, also maybe good also in simulations, but in terms of data analytics and Python and so on, I think some of you are even better than me. So I'm not saying that I'm good in everything, but of course I can show you if those things combined together, I think this will be pretty powerful to discover something new together. So that is the first principle, think free. And then now this is come to the course assessment. I think I will read this out in the Canvas page. I simply copy there, but this is a link to the principle. I talk about think free. So it is a pretty complex assessment grading scheme. But when we come to the Canvas page, I will tell you more later about this. But this is related to what I mean by think free. Try to find a level that the more suits yourself. Now, the second principle So you're studying in Uppsala University. I don't know how many of you even study your undergraduate with Uppsala University. So how many of you have visited the University Hall? Are there people here that have never visited this University Hall? I think you're now in your second year. So even for foreign student, you have been in Sweden for more than 1 year now, right? So I think a very beautiful place. I would recommend you to be there. And then you probably all know that I think Uppsala University is the oldest university in Sweden, even in Nordic countries. So do you know what is the oldest university in the world? How many people know the oldest university in the world? And anyone can write down here on the chat, or maybe you can cheat by quickly browse Google. Yeah, okay. So Andrea tried to reply. I don't know whether he find Google. Okay, and then quite early, I think it was now I don't remember the year. Must be like year 1000 something, and then not much later you find Oxford and Paris. So Uppsala was a relatively later, but still is more than 500 years. The year was 1477. But do you know that I think like all this university or older university, there was only one subject when they started. So that's why it's called university, right? So the subject that people can study is theology. And I don't know how many of you really know about theology. So, and then how can you define the meaning of a theology? So theology, some people will say that, okay, the study about God. And then the question is, can you really study God, but like putting God into a microscope? So the previous department head of theology department in Oxford, I think she answered this question in this way, is theology is about the study of speaking correctly about God. Okay, it's not about a study on God, it's about how we could speak correctly about God, okay? So why I try to say this is if you think deeper, so it's not only about theology, I think it's about anything you study in the world. So even biology, you can put an insect, you can put a spider onto a microscope. But the question is, yes, we can know about something quite deep. We can have even the knowledge to manipulate and control. But if I use a philosophical terms, how many of us really know about the real ontological structure of the things that we study? So take something very simple. We can send a rocket to the moon, and even people talk about to the Mars. But how many of us really know about the real ontological structure of motion and gravity? So if you think deeper into almost everything in the world, I think we can have very good models, and those models allow us to control, to predict the behavior. But in terms of knowing I keep using these philosophical terms, the real ontological structure of things, I think we are pretty ignorant. So that's why the second principle I want to say here is I think the quotation here, I think you find these terms on the University Hall in Uppsala University. So thinking freely is great, but thinking right is bigger. So what do we mean by thinking right? So this will be something I think is very important, even though it's a bit philosophical, but I really hope that you will understand now in your study, but also later in your career, is all models are wrong. So that is the first thing that you need to know. What do we mean by think right? By thinking right means that you know that all models are wrong. And then when I say models, and this is a common citation, I have heard about this in different presentations, sometimes in simulation conference, and people usually refer to different people. But anyway, if you just look at the Wikipedia, I think this should be coming from the statisticians, George Box. So nowadays, when you use statistics, you have something called a box plot. So this is something from George Box. And then according to Wikipedia, I think in his paper, 1976, he has the first part, all models are wrong. And then of course, when he referred to the model, he was not talking about simulation model. It was more talk about statistical, other scientific model in order to capture the data. And then today you know about the data mining. When you talk about building models, sometimes I also find confusing talking with a computer scientist, because when we talk about building model, we talk about building simulation model. But when they talk about building model, they talk about using the data to build a data mining machine learning model. Anyway, in here, I think it's quite safe to say that all models are wrong, because all models simply can capture a certain aspect, certain behavior, certain part of a real thing, whatever you talk about, whether it's a product, whether it's a system, whether it's a natural phenomenon. I think all scientific models can only capture certain aspect. But then later, I think people add the second part here is but some are useful. I think this is what we like to say inside the simulation world is that we know that all models are wrong because they cannot capture any real behavior. You can only capture only a certain aspect and then make certain predictions and then correctly according to certain measures. But they are still useful for doing something. And then, of course, in this course, we will talk quite much about analyzing the performance and even talk about decision support later. But they are useful to a certain extent. But be careful that all models are wrong. I think that is the first thing about this principle, about think right. So that when you build a model, you need to know about the limitations. And then I think the other citation here I find in also on the same page on Wikipedia. I think it's pretty quite interesting to just show you here. But something can be said about this from the French poet about what is simple is always wrong and what is not is unusable. And then normally when we deal with a mathematical model, sometimes you get a very elegant equations, but then the equation is too simple that you know that it's too unrealistic. Is useful only for some academic study, but maybe not very useful for the real problem. I hope that your knowledge related to simulation will be something in between. So you know that there are still limitations, but again, I think compared to very simplistic mathematical model, we are dealing with something more useful. Now the third one here from Picasso. Now, I think if you read this line, I think there is a certain inspiration here. Later, when we talk about what we mean by combining simulation and prescriptive analytics, we will also talk about from a management, from an organization perspective, you will have some role called an analyst and then another role called decision maker. So when you start your career, if you study industrial analytics, probably you will start to become an analyst. And then when you climb up your career ladder, later you will become a decision maker. And then sometimes for smaller organization, for simpler problem, maybe the analyst and the decision maker is the same person. Okay, but what is interesting when quoting Picasso here is, as an analyst, even though you may think that the data will tell the truth, so the truth will be coming from the data. But I usually don't see in this way. For no matter what kind of model and analytical method you will apply, I think that the human aspect is pretty strong there. You sometimes, I'm not talking about you manipulate the data, but what kind of analyzed result you try to show, how you try to present those results, maybe is already selective, you have a certain bias. So in this case, I can imagine even the analyst, the role should be quite neutral to let the data to tell the truth. But in many cases, I think the analysts already have some bias in the negative terms, but maybe preferences in the positive terms. So preferences, this term will come back later. So what I mean is you need to understand that first, the model is not the absolute truth. And then how you use the model to present the result. Maybe you also cut the truth to half as well. So this is what we mean here by we try to convince the other something we find from our model. But here, there is a certain human aspect here that we need to understand. And this probably will be something that belongs to something not pretty known to me as well. I'm a pretty technical person as well. But there are many things that you can talk about relate to organizational psychology or even psychology in general, relate to the decision making. So we will talk a little bit about that and even relate to learning. But I think this would be very good to summarize about what I mean by thinking right. That is the second principle. And finally, I want to make it shorter. This one will be much shorter. The third principle is to think about your goals. Okay. And then I have been using this citation for quite a long time now. And this one you can find in one of the textbook. I will highly recommend that all of you will read will be factory physics. So according to Einstein, is the confusion of goals and perfections of means seems to be characterizing our age. And in here, we will learn summation and optimization and data mining, and they are more like the means. But it will be the problem that defining the goals you may think. And then I usually like to use these goals in plural terms. Why is because of you always need to define your goal. And sometimes it will be easy for certain problem, but the higher related to company, then you will find that sometimes not easy to define very clearly. And then which goal should be prioritized. So this, I think I will come back later when we try to define prescriptive analytics and then the relation with AI. So I think I will come back to here. But remember this, the third principle is about think about your goals. Because of, yes, I think in the course, I will show you in terms of a standard system engineering theory, you have some standard objectives. But you can think about that when you apply to a real world setting, where you're more free to think about different level of strategy, different level of business problem, then maybe it's not that straightforward that you can define your goals. And then you have the tools, you have the means, but then the means and the goals, sometimes they are not the same thing. So I think this is the third citation. I think already too much about the principles or the philosophical part. Now, come to the simulations. Why we study simulations and not just the mathematical modeling. So this is a quite common citation I want to read for students here. I think a few days ago, I talked with one PhD student here about what we mean by complexity. Why a factory is a complex. So a factory, in a certain extent, is a structured environment. So why is it complex? So, and then like other business. So nonlinear, stochastic, dynamic, to change over time, and then variations. And then we also have a feedback. Feedback can mean the effect coming out from externally about the environment, or simply like in a manufacturing world, we have a products that coming back to have the rework. So all this will add into the complexity of the problem. And that's why normally we regard factory as a complex system and not easy for you to very simple to jump into any conclusions about decision-making or operational control. And then another citation I have been using many years, it will be about why simulation. And very strong reason is, in academic, we study about Killing models, about Patrinet. I don't know whether there are some exchange German students here. I usually can find some German students. And Patrinet is a very common modeling method they teach in Germany. But if you look at what industry use, if they really perform quantitative performance, then you will find that the first answer will be Excel. But then if they really do something related to this dynamic stochasticity, try to deal with those aspects of the complexity, then simulation is almost the only tool used, according to this German professor. So this is why studying simulation is something very interesting. And then in the previous course introductions, I show a very short Marfield's theme. I think before we take the break, I think it's good that I will show you again this film, even though I think some of you have seen it in my course introductions some time ago, but it's still good to show you this Infinity War 30 seconds something in order to show the relationship between simulation optimization and decision support. I'm quite sure that not all of you have seen it, at least not the PhD students. So before we take the break, I will show you this film. I'm sure that I share the sound. Let me see if this works.
But does your friend often do that?
Strange. You all right? Be back here.
Hey, what was that?
Went forward in time to view alternate futures, to see all the possible outcomes of the coming conflict.
How many did you see?
14,605,000. How many did we win? One.
So I think now since the end of 2019, I think every year I try to show this video in different workshops, different lectures, 4 or 5 times. Some of you have seen it. I'm emphasizing what this interesting snippet from the film Infinity War is a classical example about how you relay simulation, optimization, and decision support together. But in terms of optimization, as I try to write down here, so Dr. String, he didn't have that many optimal alternatives to choose from because over those 14,060,005 simulations, he could only find one particular alternative that, or in technical term, we call solutions. And then relate to this relations between simulations, optimization, try to find the best alternative to do the decision making. So we can also read about the relationship with AI. So this is an article from IET in the UK. I think it was 2019 about quantum computing. So the text here is pretty small. I think it's in one of the middle cover. The text here is pretty small. So I expand it a little bit for you. So you can read it here. So when the complex processing that usually take several hours through quantum computing, maybe not happening today, but it will happen very soon in the coming few years. So a few days computations can reduce to seconds. So with virtual real-time decision making from simulation, the real age of artificial intelligence could be upon us. So this IET article tried to relay simulation, not just to decision making, as you see here, and then more specific about this real-time decision making. But then the claim here is that the real age artificial intelligence is actually linked to how fast we can run simulation. And that's why you should understand that even though simulation is not really an AI tool, but this is a very important component because it gives you the predictive function there. So the predictive function is correct to a certain level, as we keep saying that all models are wrong. But the predictive function allows us to try many alternatives, and then to the end, we can make the decision. But if this decision is made by the machine, not by a human being, then this is the real artificial intelligence applications. So I think I stop here. I will stop the recording